Hey everybody, and happy Friday to you. Today in our math lesson, we're going to talk about this big, or actually both of these big words here, the commutative property. So you may want to say that slowly, commutative property. Alright, that sounds like a big, crazy math term. I'm going to show you exactly what it means. Once you get the hang of it, it's really not bad at all. And in fact, you may already do it without realizing it. So the commutative property, let me show you what that is. So when I have a math fact like this, 1 plus 3 equals what? I can solve it by starting with this first add-in and doing 1 plus 3 and get 4, right? Or I could flip these add-ins and write this problem like this. 3 plus 1 equals, will that still be the same answer? If I have 3 plus 1, it still equals 4. So the commutative property is basically when you switch the add-ins. Add-ins in addition problems can be switched into any order and they will still equal the same sum. Just flipping the add-ins is called the commutative property. Okay, so like I said, I could write this as 1 plus 3, or I could write this as 3 plus 1, and it still will come up with the same sum. Let's do a different one. What if I had this problem here? Two plus 4. Okay, well, I could do 2 plus 4 okay, and what sum would I get here? 2 plus 4 equals 6. Okay, but I could also use the commutative property and flip these add-ins to say 4 plus 2. Look, 1, 2, 3, 4 yellows, 4 plus 2. Does this still equal 6? Yes, it does. So that's using the commutative property, and that's just when you flip your add-ins. It works just fine. And remember, I talked to you earlier this week about how these number sentences or equations can be written multiple different ways. And this is just, I know I wrote these far apart, but these two are the same thing. The add-ins have just been swapped. They just swapped places. That's the commutative property. It still is going to equal 6 no matter which way you write it. Also, you could write with the sum or the answer first and do 4 plus 2. 6 equals 4 plus 2. Or 6 equals 2 plus 4. So no matter which way you write this, you are just using the commutative property to switch your add-ins. So commutative property is just switching your add-ins in a different order, but they still equal the same answer. Now let's look again, and we kind of touched on this earlier this week, about what happens when you do subtraction. Okay, so if I was given the equation 6 minus 2 equals. Okay, let's figure out what the answer would be first of all. Oh, well, I already had 6 up here. Okay, let me put them all in the same color because I started with 6. If I have 6 and take 2 away, 1, 2, I'm left with 4. Alright, if I tried to do the commutative property with subtraction and flipped it to be this, am I still going to get 4 for my answer? Well, this is saying I'm starting with 2 and I need to take 6 away. 1, 2, uh-oh. Is there enough for me to take 6 away here? Nope. So the commutative property does not work for subtraction. Because when you subtract, it always has to begin with the largest number first. Notice I have 6, 2, and 4. Out of these three numbers, which is the largest? 6 is the largest, and that's why I begin with it first when I'm subtracting. And then, as I take some away, I get a smaller number, which would be 4. So the commutative property only works when we add. I can still write this subtraction problem in different ways, like I could write it vertically, like this, or I could write it to where the difference is first. When I do that though, 4 equals, I have to make sure that I still say 6 minus 2, because 4 is going to be the same answer as 6 minus 2. 6 minus 2 is also 4. So 4 and 4 is the same. I could not write it like this though, because you can't do 2 minus 6. I know it gets kind of confusing when you put the difference first when you're subtracting, but just remember where you write the thing that you're actually subtracting, the two numbers you're subtracting, you have to start with the larger number first. Okay? Let's do another subtraction problem. How about 7 minus 5? Okay, well, let's start with 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we have begun with 7 up here, and then I need to take away 5. So 1, 2, 3, 4, 5. What's the difference of 7 and 5? 2. 7 minus 5 equals 2. Remember, we cannot use the commutative property with subtraction. So we cannot say 5 minus 7 equals 2 because that's just not possible. Okay? So you cannot flip your subtractins here. They have to stay in this order, but I still can write the problem different ways. I could still write it 7 minus 5 equals 2, or 2 equals 7 minus 5. You just can't use the commutative property and switch what you're subtracting. All right, one more for today. How about 8 plus 2? 8 plus 2. My plus sign's a little crooked there. Okay, with 8 plus 2, remember plus means I'm going to add, put together. So if I have 8 plus 2, I'm going to begin with 8. 1, 2, 3, 4, 5, 6, 7, and 8. And then I need to add 2 more. So 1, 2. All right, so we have 8. 1, 2, 3, 4, 5, 6, 7, 8 plus 2 equals what? Well, I don't even have to count because the whole 10 frame is filled up, and when the whole 10 frame is filled up, that means there are 10. So 8 plus 2 is 10. That's a making 10 fact. 8 plus 2 makes 10. I could use the commutative property to add these numbers together and do 2 plus 8. 2 plus 8 equals, it still equals 10, no matter which order I add these in. Okay, I could also write vertically, 8 plus 2 equals 10. Remember, this long line here is the equal sign when you write the problem like this. I could do 2 plus 8 equals 10. I could say 10 equals 8 plus 2, or 10 equals 2 plus 8. With addition, you have a lot more options of ways that you can write the problem because of the commutative property. So why is the commutative property important to use? Well, let me explain one thing to you, and then we'll be done for today. With the commutative property, you may get a problem like this, and maybe you don't know this problem yet. 1 plus 8. Well, if I need to start with 1 and add 8 to it, that's going to take a lot of time for me to count 1 and then 2, 3, 4, 5, 6, 7, 8. That takes a little bit longer. But if I use the commutative property, I could write it to where my largest number comes first, 8 plus 1, and that may make it a little bit easier for me to solve it, because all I have to do is go 8 and 1 more is 9, and I can solve it more quickly that way. So using your commutative property can help you to solve problems more easily by helping you to make the number sentence into one that you're more familiar with. Like instead of doing 1 plus 8, you could make it 8 plus 1 and solve it more quickly that way. So remember, with addition, you can use the commutative property to switch your add-ins. And with subtraction, you cannot switch the numbers that you're subtracting. But when you subtract, your largest number always has to be the first one in the problem. All right? I hope you'll have a great weekend. Oops. Bye.